Hello everyone, this is the video lecture for Calculus 2, Section 7.2, trig integrals. Well, you didn't have enough of it in pre-cal, right? I have nothing new to say besides get your pre-cal notes out, get your unit circle sheet, get your formulas from pre-cal out, because here we go, 72007. I got integral from 0 to pi over 2 of 9 cosine squared theta d theta. Okay, so I want to figure this thing out. I want to use trig formula somethings to make it easier. There is actually a formula for this guy. I think it's double angle formula or half angle formula, something like that. There's a couple formulas for cosine squared, by the way. I'm just looking for one that will, I guess, work better. And this is the one that I'm choosing. So I'm going to do this very often, where I'm just going to change this into that. And you're going to go like, what the heck happened? Well, it's a formula. I'll remind you that there's a formula here. I'm not going to, sometimes I write it on the side. This is the formula that I use. But I mean, it's clear that I'm just saying this guy goes to this guy. And I'm going to try to make it clear as well. But I'll be doing that all throughout this section. And then we just say, okay, now what? And we just keep on integrating. So now what? I'm going to take the 2 and move it out. At least I can do that. If you can see, I actually have a fairly simple integral now. Because there's 2 separate integrals. Integral of 1 and then integral of this cosine. So I got my 9/2. Integral of 1 is going to be x, or theta, I guess in this case. My cosine, when you integrate, turns into a sine. But the thing is that you're actually going to have to multiply it by a half because you substitution stuff. Remember that whenever you're taking a derivative, you take the 2 and you multiply it on the outside, right? Well, when you integrate, you're dividing by that number on the outside. Again, though, you can do the formal u is equal to 2 theta, du equals 2 d theta, blah, blah, blah. Just keep it simple. Keep it simple. And we're integrating this from 0 to pi over 2. And so then whenever I plug into pi over 2, I'll get numbers. But whenever I plug in 0, here I get 0. And sine of 0 is 0. So that actually will cancel in this particular case. Don't always think that 0 always cancels, especially when you're working with cosines in particular. So when I plug in the pi over 2 here, I'm going to multiply it with the 2, and I actually get just a pi. That's kind of odd, right? Well, sine of pi with the y value at 180 degrees is actually 0. And so this actually ends up being 9 pi over 4, and you're done. Continuing on. So we have integral from 0 to pi over 2 of sine squared x cosine squared x dx. I'm actually going to use the same formulas as last time. And so this one gets a cosine 2 theta, but with a minus in the top. And this one gets a cosine 2 theta, but with a plus sign in the top. Oh, I'm using thetas again. So in my notes, I switched over to theta. Well, it's okay. This time we're using x, so that's actually a little easier, actually. So I'm like looking at my notes like strictly, and yeah, I was using theta all over again. Is the answer still in thetas? No, apparently I changed back to x at some point. Whatever. Okay, so the 2's can come out to the front as a 1/4. But notice that this numerator here, I'm actually going to have to FOIL it. 1 times 1, 1 times the cosine, negative cosine times 1, and then cosine times cosine. The middle terms actually cancel one another out. Then you got a negative and positive makes a negative, and I got my cosine squared of 2x dx. So what we just made is made this guy turn into this guy. And now what? Well, you do it over again. And so I can actually rewrite this as 1 plus cosine now to the 4th? No. Sorry, it's with 4x. There it is. Divide by 2. Because it was already a 2x, basically I'm always doubling the inside. And so now it's just a 4. I'm going to just go ahead and integrate, if that's okay. So my first one, integral of 1, is going to be an x. And then over here, I got the 1/2 still in the front, and I'm going to just, I just pulled this out right here, basically, and now I'm going to integrate this thing. The 1 goes to an x, and then my cosine will go to a sine, but I have to divide by the 4 because I'm integrating. This is just like the last problem. There we go. From 0 to pi over 2. All right, plugging in the pi over 2. My 4s are not looking great today. I got pi over 2 minus 1/2. I have pi over 2 plus 1/4 sine of pi over 2, but times the 4 actually is going to make a 2 pi, and sine of 2 pi is a 0, so that'll go away. Close, close, minus 1/4. And if you plug a 0 in all these places, it'll also yield a 0. Everything here is 0, so that goes away. So you're just left with this stuff here. I got pi over 8 minus, and notice that we have, this is pi over 4, and then another 4 makes pi over 16. And so then what, I get just pi over 16? Yeah, that's my answer. Cool. That's it. Come on. There we go. Next question. 72018. So I now have tangent integral of tangent squared x cosine cubed of x dx, and go and figure it out. So in my notes, a lot of times I have things like I cross through or something, like I try this method and it does work, I try this method but it doesn't work. I actually don't have it here, but coming up very similar problem, I try something like what I'm going to do here and it does not work. So different strategies, different times. I'm just going to try something out and see if it works. In this particular case, what I'm going to do is convert everything over to sines and cosines. So tangent is sine over cosine. They're both squared still. And then this guy is just a cosine. See how I convert everything over to sines and cosines. These will cancel with that, and so I'm left with now integral sine squared times cosine dx. Okay. So, what do we do now? Well, I remember that the derivative of sine is a cosine, that kind of stuff, right? So I'm going to say that my u is equal to sine of x. du is equal to cosine x dx. And I always go one step further. Okay, well, I most of the time go one step further, where I divide by that cosine to the other side. It's supposed to be an equal sign. And so I'm going to take this one and plug them in. And so I've got now u squared times cosine x. Dx is now a du divided by cosine. And you can see the point here was that these guys cancel entirely. So I've just got integral of u squared. That's u cubed over 3 plus c. And of course, I know that that is a sine, so sine cubed over 3 plus c. And there we go. That was it. Next questions. So again, I just converted everything to sine and cosine there, and it worked. So that's great. Sometimes it works, sometimes it doesn't. Integral of 9 tangent x secant cubed x dx. Well, I know the strategy here. I know how to make this work. But if you start doing sines and cosines here, it actually does not work. I'm going to show that on the next problem. Here I'm just going to follow the straight path. So the 9 definitely comes out. I'm going to split up that secant so that I actually have secant squared x. And then I'm going to say times secant tangent. Okay, now pause for a second. Why am I doing this? Why not something else? I have just a funny feeling. I'm going to ask, what's the derivative of secant? And you're going to say secant tangent. And so that's kind of my u du thing. I'm just going to say, like, this is a u squared. This is my du. That's what I'm guessing. That's what I'm thinking. And so let me try that. Let me just say, okay, I got my secant. Derivative of secant is secant tangent. How do you remember that? Well, it's on a formula card of some kind, I'm guessing, right? But how do you remember it? Well, I have my own techniques. I say that there are always 2 secants and 1 tangent for like the whole entire thing. If you start with 1 secant, you're going to get another secant and a tangent. If you said, what's the derivative of tangent? What's the derivative is secant squared. Again, looking back, the whole here, how many total secants do I have? Well, I got 2 secants, 2 secants. How many tangents do I have? 1 tangent, 1 tangent. That's how I remember it, at least. Okay, so here we go. Plugging it all in. We got 9 integral. Now that's u squared. We already said that that's going to be my du. I'm just going to skip ahead on that one. U cubed over 3 plus the c. Notice that the 3 and the 9 are going to cancel. And so I'm left with now secant cubed. I guess you could do that. I mean, that's technically correct. I have a small pet peeve about trig power notation. But that's a whole other story. We're not going to go down that road. Especially on a recording. No way. And now you're like, man, I really want to know what's going on now. Next problem. Integral of tangent cubed x times secant to the 6th power of x dx. All right. This one's a little bit more complicated than the last one because I have a lot more tangents going on. And so I can't just say, oh, well, I'll have a secant tangent just like the last problem, we're done. Not really. So my first attempt is to say, oh, well, let me break this down into sines and cosines. Perhaps something will cancel, right? So secant is technically 1 over cosine. What you probably are seeing at this point is that nothing really cancels. These actually combine together to make more cosine, and that is not helpful. And so it's okay to try different methods, and if it works, cool. If it doesn't, oh, try something else. And so here, let me try something else. I remember that tangent here is somehow related to secant squared or something. So let me do tangent squared, tangent, and then I'm going to do secant to the 6. This guy right here, there's a formula for it. It's secant squared minus 1. I don't have every single piece of these memorized, by the way. I have my notes in front of me. But I do at least recognize my need for a formula. I recognize my need that, oh, is it, I know it's a secant squared, but was it secant squared minus 1 or was it 1 minus secant squared? You know, that kind of stuff. I'm not perfect at all this stuff. I do just, go look it up. But I at least know that there is a formula. See the point there? Okay. So why am I doing this? Well, I really wanted a single tangent by himself because my end goal is the same as the last time. I'm going to have my secant, and then here I'm going to have secant tangent. And see, notice that I had that single tangent right here. That was my end goal. Well, still, there's also a single secant. And so I need to take this one here and split him up into 5 and 1. And so I've now got secant squared minus 1. I've got my tangent. And then I've got my secant to the 5th. And then I've got a plain old secant. And what's going to happen is that these two guys here are going to be that du business. This is going to distribute into both of these two terms, yielding secant to the 7th, and then minus secant to the 5th, and then I got my secant tangent. Oops, x dx. There you go. All right. I'm just going to do this u du like I did last time. So obviously that's your du. Each of those are going to be u's. And so I've got u to the 7th minus u to the 5th du. I know I didn't divide it like I normally do. It was just like the last problem. So it's super easy here. And at this point, we should just be able to rewrite the answer immediately. Secant to the 8th over 8 minus, and then I got secant to the 6th over 6, and then plus c. And yeah, we're done. Okay, that's it. The end. Well, hold on. Little star, little note here. WebAssign has its own answer. You ready for it? Let me go ahead and give it to you. We got tangent to the 8th of x over 8 plus tangent to the 6th power of x over 6 plus tangent to the 4th power of x over 4 and then plus c. This is the WebAssign answer. So you go and get it wrong 5 times, 3 times, whatever, and it gives you this big old tangent mess. You have no way even gotten close to tangent. You got secants all over the place. How are they getting tangents, right? Well, they went a different route. There's multiple ways to get here. I don't know what they did. I'm sure there's a way that's logical, but they did something and they got tangents instead of secants. Your answer is still going to be okay. That will still work, okay? So just go ahead and type it in. If it says it doesn't work, you tell me. And then I'm going to get on tech support and say, look, this is equivalent. I went and checked it. I wouldn't have kept it in my notes if it wasn't equal, okay? So they're the same. I know it's kind of funny looking. If you want to go and, figure out why they're the same, well, see you later. I guess here's one tip and trick for the homework, okay? And this is one that you could use. If you go to Desmos Graphing Calculator and you put this one in as the first y1 or something, and this is y2, and then you see with the graphs, if they're overlapping one another everywhere, then they're equivalent. That is not a proof that it is the same, but at least it's a guide, and it says, hey, they are technically equivalent, so it should work either way. Think of WebAssign on the back end, that it has like its own little graphing calculator. And so it puts this in, it puts this in, it says, are they the same? And yeah, they are, and so we're good to go. Think of it like that, okay? We don't have to get exactly numerically what they have. We're getting the equivalent exact answer. Okay. Integral of 9x secant x tangent x dx. Now hold on, pause. This looks familiar, right? So my that was my secant turned into secant tangent. That's what was my derivative. So that must be my du here, right? That's my du. So this is my u, and whoa. No, that's not secant. That's just x. That's actually not going to help you going this way. So what do we do now? There's definitely a couple ways that you can think of going. I got x secant x. Is that a formula? How about this? What about integration by parts? So what I'm going to do is bring the 9 out to the front, and I got my u, and I got my dv, and so here we go. U is equal to x. Remember, I'm choosing u, that it's an easy derivative. So the derivative, did it get easier? Oh yeah, definitely. Like, what would be the derivative of secant tangent? And you're thinking, oh, it's secant. No. It was the derivative of secant that got the secant tangent. So the derivative here would be a product rule of some kind, and that's not very fun. And so you don't want to choose that as your u. You do want to choose it as your v, though, because when you're integrating it, doesn't it just turn back into secant? Right? Because the derivative of secant is secant tangent. So we're going backwards now, and that's how we got that. Much easier. And so then my answer is uv minus integral v du. Remember that 9 in the front? That is something I always forget about. Just watch out for that kind of stuff. It would be silly to get it wrong just because of the 9. And yes, I have done that many times myself. So these my v du there. There you go. So what's the integral of secant? And this is the, what is that answer, right? Well, there's a formula for that. If you want to actually figure out what that is by yourself, you can. I don't recommend it, honestly. So I'm just going to give it to you. It's ln of secant x plus tangent x. That is just a formula. That is just a formula. So if you could just, I don't know, memorize, write it down, whatever, integral of secant is ln of secant plus tangent. Just one of those formulas. Let's do another one. 72037. So I've got integral of pi over 6 and pi over 2 of 8 cotangent squared of x dx. There's definitely a lot of ways we can try to tackle this. Here's one that I tried. I said, hey, the cotangent, there's a formula for that. I got my 2x, and I got my 2x. Nope, that doesn't help. Let me look at that thing. Does that help you? Does that really look like it's going to be any help? No. Okay, here's another one. Let's just convert this into sines and cosines, all right? So we got a cosine squared. We got a cosecant, because, you know, it's sine in the bottom. Yeah, does that help out? No, that doesn't help. I don't know what that is. I'm lost again. I don't know what to do. Well, there is a formula for cotangent squared. Isn't it cosecant squared minus 1? Again, I don't memorize this stuff, especially that one. I'd have that somewhere nearby. And I also remember this cosecant squared as a derivative or integral or something kind of like that. And so I'm thinking back, and I've got my cosecant derivative. Derivative of cosecant is negative cosecant cotangent. Remember, there's always two of the cosecants or two of the secants. The derivative of cotangent is a negative cosecant squared. I want to use this one. Again, I'm going backwards. I'm starting with the cosecant squared, and I'm integrating it into a cotangent. But now, because it was negative, of course, I'm going to have to add that negative in there. Basically, it's negative 8 cotangent x. Here, what my integral is just 1 goes to x, so 8x. And then from pi over 6 to pi over 2. Cool. Plugging these guys in, pi over 2 of cotangent. So we're talking 90 degrees. And so I had tangent at 90 degrees would be undefined. So that's 1 over 0. And so because now it's the cotangent, you flip it and you get just 0. So now I've got 0 minus 8 times pi over 2 minus, and then I've got this pi over 6 that I'm plugging in here. That's a time sign right there in case that's confusing. So my tangent at pi over 6, that's 30 degrees, is a smaller amount. That would be 1/2 over the square root 3 over 2, so 1 over square root 3. In the end, square root 3 over 3. But now because it's cotangent, I'm going to flip it to make it just square root 3. And if that seemed like there was a lot going on in my brain, at least I tried to talk through it. Could you use a calculator? I mean, even if you had just a basic scientific, or like I wouldn't say a 4-function calculator, but something really, really basic, and you said, hey, what's the cotangent of pi over 6? And you did radio mode, obviously, and you got 0.866. Actually, I don't think you get 0.866. What would you get? It's something like that, though. Hold on. So I don't have the cotangent feature in my calculator, this one at least. So I'm going to do the tangent of pi over 6. Okay? So I got tangent, and I'm in radio mode. Yep. I can't prove this to you. I'm just going to go ahead and talk you through it here. Well, my Casio gave me the answer. But let's just say I got a 577, and that's not really super helpful there, I guess. So I know it's a cotangent, so I'm going to flip it, so 1 over my answer. And yet again, my Casio just gives me the answer. So 1 over the 577 yields a 1.732. And I'm just going to say that guy right there, he's a square root 3. You know that you have a tangent or cotangent. You're going to get square root 3s in your answers. It could be square root 3, it could be square root 3 over 3, who knows. Just be on the lookout for that kind of stuff. Double check all this stuff in your calculator. It's fine. Decimal equivalents. Okay. So I plugged it in. I got some answers. Cool. Now we actually have to do something with it. So I've got a negative 4 pi technically over there, right? That's a negative 4 pi. That negative will actually distribute, making both of those positive. And that 8 over 6 will be a 4 over 3. To make common ground over here, I've got to say that's going to be a 12 pi over 3. And so 4 minus 12 is going to be a negative 8. And so my end answer is going to be this guy here. Blah, blah, blah. Common denominator, whatever. How can I do that in my calculator? Well, what if you did 4/3 minus 4? And then you said math to frac. And, oh my goodness, you got it. Oh, wait, put a pi on it. So, I mean, there's lots of ways and tricks to do it with a calculator. I can't go through them all, but you use it. It's a tool. You'll have it for your exam. I'm talking scientific calculator, okay? Basic stuff here. But use it to the fullest, you know? Okay. This one here, it just says figure this thing out. Well, first off, there's not a lot of randomization going on. And, well, I'll just give you the answer because there's just an answer. We did this earlier, actually, on the secant version. And I said, well, the answer is just this. And that's okay. That's just a formula. And plus C, there you go. You're done. There's nothing else to do here. Walk away. Now, I am going to do just a tiny bit more. Yes, it's because I'm the teacher and I've got to do this sort of thing. But ultimately, yeah, you're done. Okay, yeah, you're done. Don't do any more. So on the back end, how are we actually getting that kind of answer? Well, they actually multiply it by this cosecant minus cotangent business on both top and bottom. You're technically not doing anything wrong. Technically. And you're like, well, where'd that come from? I don't know. Someone probably won like the Nobel Peace Prize for it or something. No, of course not. Not in math. Math gets the Fields Medal. We don't do that. Nobel, whatever it is. Okay, you might be thinking I'm weird at this point. 9 times so I distribute it, whatever, still doesn't really help me very much. What I'm going to do here is say that my denominator is my u. Oops, cosecant. Man, just put 2 C's in there. Come on. Cosecant minus cotangent. And so then my du would be this guy here. I need a little bit more room for this. My du would actually be a negative cosecant cotangent plus cosecant squared. Notice that I didn't put x's. It's because I'm super lazy. But this right here looks strangely familiar to this guy right there. Like it's a copy-paste, basically. So u du kind of stuff. We got 1 over u du. Of course, what's the integral of 1 over u is ln. And now I can just plug back in what I had, which was the cosecant minus cotangent. Okay. Cool. Now you got the same answer twice. You should feel good about that. Yeah, twice. Next one. So I got integral of 7 times the sine of 8x times cosine of 5x dx. So what's the trick here? There's always a trick, right? Move the 7 out for sure. This has got a special feeling to it. If you remember, there's formulas near the bottom of that one trig formula page thing. It looks something like this. 1/2 times, and then I got my sine. Is it sine or is it cosine? Yeah, sine of u minus v. And then I've got my sine of my u plus v. Does that look familiar? Anyways, that's my formula that I'm going to use for this guy. So it ends up looking like, pretty simply, I got 1/2 times this whole thing here. Sine of 8 minus 5 is 3x. There's a plus sign in the middle. Yep. And then when I add them, I get 8 plus 5 is a 13x. Close, 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 dx. I gotta have all those parentheses. So important. Well, my integral of each of these is actually pretty simple. And so my integral of each is going to be a negative cosine of the 3x. Again, remember to divide by the 3. Here again, I'll go to a cosine. The 13x, divide by that 13. And then plus c. Is that it? Yes. You're done. Just type that in. You don't have to simplify. It's fine. Cool. Next one. 72065. Ooh. Kind of weird there. Okay. We got y is equal to sine squared x. Got y is equal to sine cubed x. And then I've got x is between 0 and pi. It says find the area between them. Find the area between. I'm going to say that drawing a picture would really help. And so I have like a big hump, and then I've got this kind of hilltop thing. It actually reaches to the top. And we're going to find the area in between those guys like this. And I'm guessing that that's pi, because this is 0. All right, so that's what we're looking for. Top minus bottom. If you get a negative, make it positive. The squared is actually going to be on the top. Top minus bottom. And there we go. Oh, wow. I turned a page and it's just a whole page of math. How do we do this problem? A whole page of math. What I'm going to start with is the fact that we got sine squared, and then a regular sine. So what I can do is factor a sine squared out to the front here times 1 minus sine. Now that doesn't super help me right now, but I can say that this guy here is going to be that cosine business. And so what happens is that I got 1 minus cosine 2 theta. Oh, gosh, I did the theta again right there in my notes. I'm just so used to the thetas when we were doing them in pre-cal. Sorry. It's just an x. It's fine. Okay, still doesn't really help me. Well, the 2 can come out to the front as a half, and then I'm going to actually FOIL this thing out, and, well, hopefully we get some kind of math. So, there you go. 1 minus sine x minus cosine 2x, and then finally, I've got a positive cosine 2x times sine x, and then dx finally. Okay. Apparently my thetas and x's are just all over the place on my notes. That's always fun. Cool. I'm just verifying that I've got the same thing here. Oh, I converted it. I see what I did. Okay. Well, I said, oh, well, there's a formula for this one. That's going to be the double angle formula for that one in particular. There's always another formula. Do you have all your formulas memorized? Obviously, I don't. But I do have the idea to go look it up. That's something. Distribute. And what you actually get here is a single sign, and it combines with this guy to make 2 of those. Didn't I say it was going to be a whole page of math? So we got 2 of those guys. Okay, we got that guy. And then we got this cosine squared x, and then I got a sine x attached to him. I'm going to say my u is equal to cosine x. So du is equal to negative sine x dx. Dx is equal to du over negative sine x, just for this one. Everything else is fine. And so what I'm going to do is just actually integrate all the rest, if that's okay, without this u stuff. So first off, integral right here, I get an x. Integral of the sine will go to a negative cosine, but the two negatives will cancel, make a positive. This guy here is actually going to just be cosine, negative cosine, I guess, can go to a negative sine, but we're dividing by that 2 now. And then finally over here. And so I'm going to say there's definitely a 2 in the front, integral of u squared du in the end, because it cancels and Oh, actually, look. Whoa. That's why I wanted to do this the slow way. Hold on. Sine x du over negative sine x. You see the small difference? I cancel these. Right, but there's a negative now in the front. Let me go ahead and start distributing that 1/2 in the front there. Now it's going to be a sine with a 1/4. And then the 2 1/2 should cancel. Remember that I just said it was going to be a negative in the front. So integral of u squared du. Of course, I already know that. To be u cubed over 3. What was my u? Was my cosine x cubed all over 3. You can make it on the inside and pretty if you like. That's whatever. And then what? Plus c. Ha 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 ha. Whoa. Hold on. It was a definite integral. So we actually have to keep going. 0 to pi. And you thought you were done. You're not. You're never done. Not in calculus 2. So 1/2 pi plus, what's your cosine at pi, is going to be a -1. And then plugging in a pi here, it should yield a 0. And plugging in a pi here, again, I get a -1. 2 negatives make a positive. I got the 1/3. So all that's just plugging into pi. Now if I plug in 0, 0 it out. Cosine of 0 is a 1. Sine of 0 is a 0. And then cosine of 0 is a 1. So we got a -1/3. Calculator, blah, blah, blah. And I get pi over 2 minus 4/3. There we go. Whew. Hopefully that works. If not, well, you tell me. I'm done. That's all I got. Thank you very much. Have a great day.